Hi everybody, we're going to do a quick little surface area recap video, do just a couple practice problems together, maybe one of each type of solid, and then I'll let you be and you can do a little bit of work on your own. So first thing, let's make sure from the last day or two that you have the proper formulas and you understand what everything stands for and how and when to use them. So if you are making a list, make sure this list is complete. If you need to start a new list, go ahead and write these out now. We're going to use capital S, capital A for surface area. So surface area of a prism, we talked about unwrapping that prism and thinking about what the different flat surfaces would look like. So we've got two congruent bases. So we're going to do 2 times whatever that base area happens to be. Now, this part of the formula, you really need to insert a formula within this formula. So you'll insert the proper area formula here. You know, if the base shape is a trapezoid, you'll put in this parentheses here 1/2 base 1 plus base 2 times height. If it's a triangle, you'll do 1/2 base times height. So this part comes out, new little formula goes in its place. Okay, that takes care of what we usually think of as the top and the bottom of the prism. And then that lateral surface that we would unwrap is one big long skinny rectangle. So it's really just base times height. But the long base of that, because of where it sort of came from, think about if you were to wrap it back up, it would go all the way around the base. So this is really the same as the perimeter of that base shape. Now a cylinder is very similar, but we know there's fewer options, which actually I think makes the formula easier because the base is always a circle. So instead of just generic base area here, it's always going to be 2 pi r squareds, that's the circle on the top and the bottom. And then instead of perimeter, well, that's circumference, that's what this parentheses is here, and then the height of the whole thing. Now I'm going to recommend, and we'll do this when we do some practice problems together, this first step of every problem is just to outline the thing that you're calling the base, because it might not always be on the bottom, and you're going to label the capital H height. That way when you get to the formula, you kind of have everything ready to go, you know what goes where. Now a pyramid and a cone, the big difference here is we have only one base, and that lateral surface is treated a little bit differently. So let's recap a pyramid real quick here first. Just a single base area. You still need to insert the proper area formula here. Usually we're going to see these as regular polygons. So often this is 1/2 ANS, but it could be other things. This, because when we unwrap that lateral surface, it's not about a bunch of rectangles, it's a bunch of triangles. And just like we did when we cut that circle out and made a bunch of wedges and kind of alternated them like point up, point down, and we made this kind of long parallelogram thing. If you look at the base of that, it's not the full perimeter, it's only half the perimeter. So this capital P is still perimeter of the base. And then we don't want the height of the actual pyramid. That runs straight up through the center of the pyramid. But we're talking about the surface. I don't care about the middle of it. We want this, lowercase l stands for slant height. It is the height that sort of falls right on one of those triangular faces. And we'll see that in a diagram in a second. A cone is very similar, but again, we don't have a changing base shape. It's always a circle. So here's our base area right here, pi r squared. This is half the circumference. Instead of 2 pi r, it's just 1 pi r, still times the slant height. So these are very similar. We just replace perimeter with circumference. We just replace like generic base area with area of a circle. So let's try one of each. If you need to pause this, you can. We're going to go get our yellow packet. We're going to do a couple problems together, and then I'll let you try some on your own. Okay, so yellow packet, find lesson 8.7. Let's pick out one of each kind. We're going to do maybe 2, 3, maybe 4 and 5. Okay, so number 2 to start. Step 1, every single time, figure out what your base is. So I want you to pause for a second and just think about that. What shape of this, or what shape is the base of this prism? That's not a pyramid, it's a prism. When we're picking out the bases, we're looking for 2 kind of congruent matching polygons across from each other. It's either this triangle that falls on the bottom, or notice there's a matching one right on top above it as well. The other faces then are rectangles, which is what makes this a prism. So when we talk about base area, it's the area of this red triangle right here. That means the capital H height. How far apart are the bases from each other? That's this length, which is 6. So I'm going to label my height, outline the base every time before we start the problem. Okay, so now surface area. Let me get this smaller. We've got 2 base areas. Now remember, we insert a formula within a formula. This base shape is a triangle, so right here goes 1/2 base times height plus the perimeter of the base, we'll figure out what that is in a second, times the height of the whole entire prism. Notice there's 2 different h's here. This is the height of the triangle that's laying on the bottom. This is the height of the entire prism. Okay, so let's start plugging some numbers in here. We've got, let me just leave this as is, the base and height of the triangle. Because this is a right triangle, you can actually just use 5 and 12 because they're perpendicular to each other. The perimeter of the triangular base, we're back to this outlined base again. I'm going to steal this 13 and just scoot it down here. That's how long this kind of slanted side is. So the perimeter is just 5 plus 12 plus 13. Remember, it's the perimeter of the thing we outlined, of the triangle. And then times this capital H height of the whole thing, 6. I would recommend do this in 2 steps in the calculator. Get a number here, get a number here. So base areas, lateral area, and then at the end add them together. That's just a lot to try to plug in at once. So that the 2 bases together add to 60. They're each 30. And then the lateral area, if we added up all of those individual rectangles, that would be 180 square centimeters. So our surface area altogether is 240. And I don't know if it says, oh yeah, it says all measurements are in centimeters. So 240 square centimeters. Now remember, one approach for particularly a prism, and maybe you would do this in number 1, you can just find all these little individual areas and add them up. You could find 2 triangles and 3 rectangles and add them all together. This is just sort of an efficient way to do that. Okay, so that's number 2, prism. Most important thing again, outline that base, mark the height. Number 3, we're still going to do that same thing, outline the base and mark the height, although I think it's a little more obvious here. The base is this circle. The slant height, that's what we want. That's this 12.4. We don't actually care about the true height. That would be, let me draw that in here. This thing running, wouldn't be so crooked, running through the middle here is the actual height of the cone, but that has nothing to do with the surface, so we just ignore that. Okay, so here we go. We're going to write our formula down to start. Surface area is now just 1 base area, but it's always going to be a circle. So a single pi r squared plus pi r L. That's half the circumference times the slant height. This one's pretty easy to use. There's not a lot of info you need. So let's just plug in 8.5 for our radius. Don't forget to square it here. Plus pi times 8.5. Be careful with your decimals and multiplication here. You might want to switch to parentheses. Times 12.4. I would still do the same thing. Make this one single number. Make this one single number. And in the end, add them together. When you do that, you should get about 558.1 square centimeters. Okay, if you're not getting that, make sure you're breaking it up into 2 parts so there's not an order of operations issue going on. I'm going to skip number 4. I think this one is straightforward enough. You just have, you've got to follow the formula. This is a cylinder. The only thing you want to be careful about on this one, the radius is the only thing we want here, so we would use 6.5 and not 13. But let's jump to number 5. So this is a pyramid. By the way, let me stress the importance of knowing what these things are called, because if you don't, we don't know which formula to use. Okay. All right, so they give us a bunch of info here. We've got this apothem is 5.2. This side length is 6. The slant height, see where this is lying on the edge of this kind of face of the triangle? That's the number we want. That's 9. Okay, so for a pyramid, we just have a single base. So base area, in this case, this is a regular polygon. It's a hexagon, so we use this formula, 1/2 ANS, plus half the perimeter of the base. You know what? Let me go back and do what I said we should do. We should outline that base. And then times the slant height. This 9, let me put over here. This slant height is 9. Okay, let's plug in what we got here. So our base, 1/2 ANS, looks like this, 1/2 times 5.2. Number of sides is 6. We're still talking about that thing on the bottom. S they give us is also 6. Okay, so 6 sides that are each 6 centimeters long, right? These are all 6 going around here. And then, so that takes care of the bottom. Now for all of these triangles, we want just half of the perimeter. The perimeter is, again, of this hexagon, 6 plus 6 plus 6 plus 6 plus 6 plus 6, or 6 times 6. You could just make that 36 right away if you'd like. And then times our slant height of 9. Again, make this a number, make this a single number, put in the calculator, add them all together. We should get about 255.6 square centimeters. Okay, let me give you your assignment. Look at this next screen carefully because each class has something a little bit different to do. Honors Geometry, you're going to try the problems on page 13 in your note packet. If it did not copy well, I attached a better copy to Schoology. You can pull that one up. Sometimes, those things don't get shaded very well. Academic Geometry, you're going to start the test review, which we will continue Monday. That is posted on Schoology. Print it if you can. If not, just work on it on a blank sheet of paper. I'll give you a copy tomorrow. For everybody, the test is now Monday. So tomorrow we'll recap any surface area questions that you have. We'll do some review together. You'll have the whole weekend to review. So our test will be pushed back till Monday now. Okay? Email me if you have any questions. I'll see you guys later.